Hi, geometry students. Mrs. Fallon here. We are on Unit 9, which is our trig unit for this semester. So this is actually a really important unit. We're going to be going over some rather, I think, fun topics and so forth throughout the course of this kind of long unit. And so what I would like to encourage you to do is if you have questions along the way, please make sure that you are asking your teacher, asking for help, because this is one of those units where if things start, if you don't really kind of understand things as we go along, it doesn't, it kind of snowballs. And so we really want you to make sure that you're asking questions if at any time you feel a little bit unsure of what's going on. All right, so we're going to go ahead and get started on page 244 of your student journals. We are on lesson 9.1. The first thing I just want to talk a little bit about is something called a Pythagorean triple. And so you might have heard of this before when you've talked about like the Pythagorean theorem. And so what it is a set of positive integers. So what that just means is, sorry, can't talk and write. So it's all numbers that are kind of greater than 1, basically, but no decimals, no fractions. And that satisfy the equation a squared plus b squared equals c squared. So this whole section is just kind of about Pythagorean theorem. And so I know you've done a little bit of work with this in geometry or in your middle school classes and so forth. And so if this is review, great. This is not something that's going to be overly challenging for you then. And if this isn't, well, then this will kind of get you guys caught. So this is just kind of what they say by a Pythagorean triple. So these are 3 integers, right? So 3, 4, and 5 is a common Pythagorean triple. And what that means is that if you were to plug them into your equation, a squared plus b squared equals c squared, it would work. In other words, the left side of your equation and the right side of your equation would equal the same value. So for example, with the 3, 4, and 5, I would start by going, a squared plus b squared equals c squared. How you know what number goes where? It really doesn't matter. In terms of what goes in C is very specific, and that's always going to be your largest number. So if you're given 3 values in a Pythagorean triple, your largest number has to be C. And then in terms of A and B, it really doesn't matter if you put A as 3 and B as 4 or vice versa. You get the same answer regardless. So what you will notice, whoops, not squared. I get 9 plus 16 equals 25, and so I get 25 equals 25. So this is how we know that 3, 4, 5 is a Pythagorean triple, because it works in the Pythagorean theorem, and that's kind of what we're getting at. So these are a bunch of, common Pythagorean triples. Notice that a Pythagorean triple doesn't always have to just be numbers. We can look at it in terms of variables. So like 3x squared plus 4x squared has to equal 5x squared. And so this kind of works the same way. Remember that when you square 3x, you're squaring both the 3 and the x. So you get 9x squared. Same thing with the 4. And then same thing with the 5. And so as you will see here, I get 25x squared equals 25x squared. And that's how you know that 3x, 4x, and 5x is a Pythagorean triple, because both sides of my equation equal the same thing. So again, it doesn't have to equal numbers. We can use expressions kind of in some of these as well. And that's kind of what we're going to be looking at. All right, let's turn to page 245. So there's some theorems, of course, in geometry. We talk a lot about theorems in converses of theorems and so forth. So we know the Pythagorean theorem, right? Pythagorean theorem states, again, only for right triangles, that if you have a right triangle, let me read it to you exactly. So it says, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. And so this is always one that we have kind of already committed to memory, right? A squared plus b squared equals c squared. What I need you to remember out of that is that only works for right triangles, okay? Only works for right triangles. And so what this converse is saying is if a squared plus b squared equals c squared. So if we have 3 values, this relationship works, then this triangle has to be a right triangle. So we're going to get into things where we're going to determine the type of triangle. So whether it's a right triangle, an acute triangle, an obtuse triangle. So just as a recap, remember a right triangle is a triangle that has, well, you guessed it, a right angle. So we call that a right triangle. An acute triangle has 3 acute angles. So remember, acute means numbers that are less than 90, so between 0 and 90. So this would be an acute triangle. And then an obtuse triangle is a triangle that has 1 obtuse angle. So imagine if this was like 120 degrees, for example. So an obtuse angle is an angle that's between 90 and 180. And this is what we would call an obtuse triangle. So what we're going to get at is we're going to get into classifying the types of triangles using the Pythagorean theorem. Okay, so Pythagorean identities theorem. So what this states is we already know if a squared plus b squared equals c squared, then we know it's a right triangle. So if this holds true, it has to be a right triangle. The other thing that we want to know is that if a squared plus b squared is greater than c squared, it's an acute triangle. And if a squared plus b squared is less than c squared, it's an obtuse triangle. So the Pythagorean, we call this Pythagorean identities, basically is getting at the fact that, you know, depending on what situation you have, you can identify the type of triangle based off of that. So let me give you an example of what you would be expected to do. So you might be given a triangle. So I'm just going to kind of write an example down here. And you might be given, whether you give a picture or just some side lengths. So I'm just going to give you both, I guess. So I'm going to give you 3 different side lengths. And I'm going to ask you, what type of triangle is this? So determine the type. So when I say that, what I'm asking for is this, a right triangle, an acute triangle, or an obtuse triangle. So what you're going to do is you're going to set up the Pythagorean theorem, but you don't really know if it's equal to, less than, or greater than c squared. So I'm going to kind of put a box here just to kind of say, well, I don't really know what's in there yet, but I'm going to try to figure this out. The other thing is you have to identify, just like I mentioned earlier, that it doesn't really matter in terms of like A and B are less important, but you do need to know what value goes in for C. C is always your largest value. So as you can see here, we have 2 root 30, and sometimes that gets a little confusing, like what approximately is this number when it's written in this form. So I'm just going to change that to a decimal just for the sake of looking at these 3 values. So if I look at 2 root 30, 9, and 14, I recognize that 2 root 30 is not my largest number, right? 14 is my largest number. And so why that's important is because, well, then I can plug them into the right spot. However, I don't want to plug in a 10.95. I want to use the 2 root 30 because it will be more accurate. So it'll look like this. So A would have to be either 9 or 2 root 30. Same thing with B. And then C is going to be 14. So it would look like that. All right, so let's practice this. So this is something I definitely want you to be able to practice. So 9 squared we know is 81. 2 root 30. So if this is confusing to you, remember what you're doing here is you're doing 2 root 30 times 2 root 30. And so numbers with numbers, so 2 times 2 is 4. Root 30 times root 30. In this case, any radical multiplied by itself, any square root multiplied by itself is just its number. So like root 30 times root 30 is 30. So 2 root 30 squared is 4 times 30, which is actually 120. And then 14 squared is 196. So just grab my calculator. So if I put this together, I get 201 and then 196. And so now what I can conclude is that a squared plus b squared is greater than c squared. So a squared plus b squared is greater than c squared. So what type of triangle is this? This must be an acute triangle. And so that's ultimately what we're doing here. We're just kind of classifying triangles. All right, let's take a look at your extra practice. I'm not going to do a bunch of these, but I just kind of wanted to give you guys an opportunity to kind of practice this on your own. So there's not a whole lot in this video. A lot of this will be you practicing and coming to class kind of, you know, with any kind of questions and so forth. So what you're doing here in this first section where it's 1 through 6, it says find the value of x, tell whether the side lengths form a Pythagorean triple. So what you're getting at is a Pythagorean triple has to be integers, which means in that last example I gave you, where's that at? The last example I gave you, on this side, this would not be, so these three numbers here are not a Pythagorean triple. Because if you remember what we said about a Pythagorean triple, it's a set of positive integers. 2 root 30 is not an integer, right? It's a decimal, or in this case, a rational number. So we know that those are not this. So you wouldn't classify 9, 14, and 2 root 30 as a Pythagorean triple. So what you're getting at here is you're going to solve for x. All of these are right triangles, which means you're going to use the Pythagorean theorem. And then once you are done solving for x, you're going to say whether or not it's a Pythagorean triple. So I'll just do number 2. So I would start by writing my formula for Pythagorean theorem. And I'm going to plug in the numbers in the right spot. So if you notice, 8 is your hypotenuse. So 8 has to be C. So I'm going to do the math here. I'm going to take 64, and I'm going to subtract 16, and I get 48. Always leave your answers in reduced radical form, which means I don't want decimals. So in 48, we know that the largest perfect square that goes into 48 is 16. So B, because we're talking about the length of a side of a triangle, number 1 can't be negative. So we know that it's not going to be plus or minus, even though algebraically that's right. For the context of this problem, we're talking about a triangle. That can't be true. So anyway, we're going to get 4 root 3 as my value for x. And so we got x equal 4 root 3. And then it says, tell whether the sides form a Pythagorean triple. And I would just write no Pythag triple. And the reason why it's not a Pythagorean triple is because 4 root 3 is not an integer. And then what we're going to have you do is try a couple, try a story problem. I'm not going to go over this one. I'd like to see what you guys can do with that. And then the last thing, verify the segment lengths form a triangle. Is the triangle acute, right, or obtuse? So again, what we're getting at here is we're asking you to kind of do that example that I did on the previous page, where you're going to kind of put them into the Pythagorean theorem, and you're going to see if a squared plus b squared equals c squared, if it's greater than c squared, or if it's less than c squared, and that will determine if you have a right triangle, an acute triangle, or an obtuse triangle. All right, that's all I need for you guys to do for right now. So go ahead and practice this. I would encourage you to practice, the extra practice here, and then of course on Big Ideas, there's some additional practice. All right, bye for now.